everybody's higher and higher.
Assalamualaikum and a very good morning to Dr. Haryati, fellow presenter and my fellow friends. So today Group 7 will be presenting about the recent advanced protein purification, which is liquid triphasic flotation system. With pleasure, welcome Group 7.
Assalamualaikum and good morning. I am Ainul with SMBT. So today our group 7 will present about protein extraction and purification using liquid triphasic flotation system. So this is the outline for our presentation. First, we are going to introduce introduction to liquid triphasic flotation, then operation of LTS, optimization of operating parameters of LTS system, then comparison with TPP and LPF, then advantage and application of LTS. So the first one, this method is downstream process, which means to produce the product. And so the first one, we are going to know what is the background problems of this before the emergence of this method. So the first one is downstream processing involve multiple operations. So conventionally, we know that to do biomolecule extraction, we will involve multiple steps, which is centrifugation, filtration, and etc. So by having multiple unit operation, this will lead to the second and the third problem, which is time and energy consuming, and it is also expensive cost for product. For the last problem, it's the additional stirring process that required for the formation of three-phase is not favorable. This is involved in TPP, three-phase positioning. By having this problem, the solution that come out is liquid triphasic flotation system (LTF). So what is LTF? LTF is the combination of two advanced techniques, which is the first one is liquid biphasic flotation, and the second one is three-phase positioning, and then it becomes liquid triphasic flotation. So in liquid biphasic flotation, it uses a bubble to act as catalyst, and in three-phase partitioning, it will have three-phase formation occurs that in the intermediate layer, it is the desirable protein that we want.
Good morning everyone, my name is Lokami. So I will introduce you the operation of the liquid triphasic flotation system. So how exactly the LTF is set up? So the apparatus included is first, a customized 50 ml glass chlorine with a sintered glass tip at the bottom with G4 porosity. Second, a source of compressed air. Third, a flow meter, and finally a pH meter. So the material included in the system such as the amino sulfate, the tertiary butanol, the tri-HCl buffer, and finally for the pH adjustment, we include the HCl and NaOH. As a general procedure, set up the LTS system by connecting the 50 ml glass chlorine with the air pump. Dissolve the sample in deionized water and get it mixed well with the salt solution. And then next we will add the solution into the LTS system, which we have already done in the first step, which contains the desired concentration of alcohol to form a triphasic system. Next, we will introduce the air bubble with the air flow rate of 20 to 25 cc per minute into the system for 10 minutes and leave the system to settle for 5 minutes before we transferring the whole system into a 50 ml Falcon tubes. And next, we will allow the mixture to settle for 30 minutes to form the three distinct phases, which the top phases include the organic solvent phase, the second will be our protein precipitate, and the bottom will be the salt phase. And then finally, we will separate the top and bottom phases from the system into separate using the micropipette. So this is the picture, the layout of the whole LTF system. In order to give you the real example of this system, we already referred to a journal that actually they use the LTF system to extract their protein from a species known as Chlorella vulgaris SPE. So, as the same as before, the material included are listed as here. So, the first one is the salt aminosulfate, tertiary butanol, tris HCl buffer, the Bradford reagent for the protein acid, and then finally the sodium hydroxide and hydrochloric acid. So, the experimental setup is that the gas chlorine with a sintered plastic is prepared. The bottom joint of this gas chlorine was connected to a source of compress A, and the air flow rate of the system was regulated by using a flow meter. So, next we will move on to the sample preparation and also the aqueous phase preparation. So, to prepare the aqueous phase of the LTS system, salt solution was mixed with the microalgae biomass. Before mixing, a pre-treatment of the cell disruption step was performed by subjecting the microalgae biomass to a sonation using the ultrasonic bar. An initial of solid biomass was vortexed in 8 ml of deionized water. The solution was inserted into the ultrasonic bar for 5 minutes using a frequency of 25 kilowatts with 40% of power at the room temperature. Finally, the pre-treated biomass was mixed with the aqueous solution consisting of 1 ml of salt and deionized water to mix up to a 20 ml system. Next, I'll pass to you about the whole system with optimization parameters.
I'm Sasi Kumar, and I'll be talking on the operating parameters. Okay, let it be any type of chromatography or purification system. Several parameters need to be optimized in order to achieve better purification and extraction, and same goes to liquid triphasic flotation. However, in this case, there are 7 parameters that has been optimized and studied for better protein extraction and purification, and such parameters includes the type and concentration of salt, the concentration of solvent, chi-butanol, concentration of biomass, and the volume ratio of salt to butanol, pH, and also air flotation time. For the type of salt, in this study there were 4 different types of salt studied to find their suitability with chi-butanol. The salt was studied was ammonium sulfate, magnesium sulfate, dipotassium hydrogen phosphate, and sodium sulfate. And ammonium sulfate had achieved the highest recovery and efficiency, and the principle that lies behind ammonium sulfate is the ionic strength generated by the ammonium sulfate leads to the protein precipitation via salting out. And there is also another point to be noticed. The sulfate salts performed better compared to the phosphate salts, and this is due to the presence of the sulfate anions, which has the higher ionic strength compared to the phosphate salts. And for the concentration of salt, 40% volume by weight ratio had achieved the high recovery and highest separation efficiency, and this is being chosen to be further studied. And any insufficient salt concentration leads to no formation of cosmotropic system. Meanwhile, extremely high salt concentration results in the protein denaturation. And for the concentration of T-butanol, the main reason why T-butanol was chosen out of any other solvent is because T-butanol is miscible with water due to its long alkyl groups. And in this case, 70% of volume by volume had achieved their highest recovery and also separation efficiency, and this is why it was chosen. And for the concentration of biomass, the biomass that was used in the study was Chlorella vulgaris, and it is an important parameter since it maximizes the cost efficiency. And the 0.5 had achieved the high recovery and also better separation efficiency. However, further reduction for 0.25 had achieved the highest recovery. However, the separation efficiency was undesirably low. That is why it was been fixed to 0.5% volume by volume ratio. And followed by that, volume ratio from salt to alcohol. We found out that the insufficient of T-butanol had resulted in poor performance. However, when we increase the amount of T-butanol, the protein becomes denatured. So we found out that 1:1 ratio was the best and suitable, and as it's also gives the best recovery and also separation efficiency. Moving on to pH. The pH 5.54 was the suitable and give the highest recovery and also separation efficiency. Any pH that is below or above it cause the undesirably low separation efficiency. And last, air flotation time. Air flotation time. The purpose of doing air flotation is because it accumulates the precipitated protein to the intermediate layer, and this is done by introducing gas bubbles into the system. The gas bubble that has been introduced for 10 minutes has shown the highest recovery as also the separation efficiency, and any further flotation will lead to the extraction of other biomolecules, and it also affects the quality of the extracted protein since it causes unwanted oxidation. And now I will pass down to my next member.
Good morning everyone, my name is Iman Josinel, and I would like to give an insight on 3-TPP, which is known as the three-phase partitioning. So TPP is actually a simple, cheap and effective system that is comprises of 3 distinct phases, which is the upper organic solvent phase, as you can see in the diagram shown on the right side, and then which is T-butanol, and I will further explain why T-butanol is chosen. And next is the interfacial protein precipitate, which is the middle layer, and lastly the polar molecules in lower salt phase, which is the bottom layer. So one of the reasons why T-butanol is chosen due to its high boiling point and low flammability, which is why it is the best candidate for the organic solvent, especially to be used in TPP due to its high purity level and during protein extraction. So another reason is, for example, high purity level extraction is when the desired protein will be separated in the middle phase, which is the interfacial protein precipitate, while the contaminants will be removed either to the top part, which is the solvent phase, the T-butanol, or the lower part, which is the salt phase. Next, it also inhibits protein denaturation due to its larger molecular size, which doesn't allow it to permeate into the folded protein. But however, there is a limitation in this TPP, which is the additional stirring processes that are required for the formation of 3 phases is not favorable, as it requires larger energy to do so. So next, for the TPP versus LTF, so the comparison is done in protein recovery and separation efficiency. So in TPP, basically they have lower protein recovery and separation efficiency with 65.93% and 43.35% respectively, while LTF has a higher one, which is 71.74% and 48.33% respectively. So this table 1 shows the operating parameters, which is varied for TPP and also LTF system for protein extraction from vulgaris. Then LTF has a higher yield because it is the integration with LPF and TPP, which is the LPF that is explained by my friend Linda. And thus it yields in a higher protein recovery from chlorella vulgaris and also a higher separation efficiency.
And my name is Nara Ashika Binti Hussein, and I will be presenting on the comparison of LPF method to liquid biphasic flotation system. So, liquid biphasic flotation system was first introduced in 2017 by PL Show's research group. So, it is a unique and one-step procedure for downstream processing, and it is quite high. It is high efficient separation and recovery and purification technologies for biomolecules. This method involves 2 immiscible coexisting liquid phases in equilibrium with injection of a bubble stream in the system. And the principle of the liquid biphasic flotation system is quite similar to the LPF method. Okay, the differences between LTF and LPF method is in the LTF, it uses a mixture containing salt solution and T-butanol, which later will form 3 phases, which are bottom phase, intermediate phase, and and top phase, and the extracted protein will be accumulated in the intermediate phase. While in the liquid biphasic flotation, it uses a mixture containing salt solution and alcohol or polymer, which later will produce two phases. And the protein will be at the top phase, which is alcohol or polymer phase. So there are a few limitations of liquid biphasic flotation system, which it only suitable for low loading sample, because if it use high loading sample, it will decrease the LTF performance. And the second one is it only suitable for low concentration of the sample, because if it is use high concentration of the sample, it will increase the contaminant in the column or in the system. The third one is in the LBF system, we use alcohol or polymer as a top phase. So if it use alcohol, it's much better. But if you use polymer, it is quite difficult to separate the protein from that polymer. And also that polymer is cannot recycle. It means that in LBF, it is quite expensive compared to the LTF. So because of this limitation, LTF, which is liquid triphasic flotation system, is invented to improve protein separation. That's all. Thank you.
Okay, my name is Norahanis binti Zaini. Okay, next is the advantages of LTF. First, LTF has a lower energy consumption compared to crystallization, because in crystallization, the solute needs to be heated, stirred until dissolved, and also filtration. Next is LTF system is less expensive and easy to operate. By using LTF in protein extraction, the system will be not complex as ultrafiltration, because in ultrafiltration, the transmission of protein is affected by properties of the membrane. And the last one, LTF system combines the benefit of LBF and TPP, which is the liquid biphasic flotation and three-phase partitioning, in order to produce more effective operating method and also overcome the current difficulties faced for protein extraction. Okay, next is the application of LTF. In the coming future, LTF could be one of the major methods used in bioprocessing industries such as food, pharmaceutical, and also cosmetic, where these protein-based biological products with exceptional purity are in demand. So in conclusion, LTF is one of the best methods that could be used for protein extraction and purification. The potential recovery and extraction of protein by using LTF as a rapid and cost-effective will be beneficial for produce high-quality product with less prices. So that's all from us. Thank you.
Group 7 for the great presentation. So now we open the question on the floor. Any question? Okay, Hamida.
Can you explain the principle of using air flotation in this case?
It introduces air bubble into the system. So the air bubble, because of the surface, the absorption of the surface active compound will actually absorb onto the air bubbles. So actually the air bubble will act as a transport vehicle to bring up the contaminants up to the organic solvent. So whenever like the air bubble have reached the highest limit, it will dissolve. So everything contaminants will stay to the top phase. So it will not disturb the intermediate layer. Yeah.
Thank you. Can we have one other question?
So my question is, can this LTF system expand into industrial scale?
This liquid triphasic flotation system could not be expanded to large scale because this precipitation of protein requires adjustment of pH. So in large scale, we need to use the toxic solvents such as HCl and NaOH, and it's also difficult to be monitored since we need to adjust the pH to 5.54.
Okay, it's clear. Thank you for your presentation and the answers. That's all. Thank you.